Welcome everyone. I'm excited to kick off today's session with a focus on Java strings. Today's presentation is titled Detailed Java String Interview Questions with Explanations and Real-World Use Cases. We'll be exploring common interview questions, understanding their explanations, and seeing how they apply in real-world scenarios. Over the next few slides, we'll dive into key concepts, best practices, and practical examples related to Java strings. Let's get started and make this a productive session. Let's start by understanding what a string is in Java. A string is essentially a sequence of characters that we use to represent text. Think of it as a way to store words, sentences, or even symbols. For example, if I write string name, Java, I'm creating a string variable called name that contains the word Java. Strings are incredibly important because they allow us to handle all kinds of text data in our programs. For instance, in real-world applications like user registration systems, strings are used to store information such as usernames, email addresses, and physical addresses. So whenever you're working with text in Java, you're often working with strings. They are fundamental building blocks for many features in software development, helping us manage and manipulate text effectively. Once a string object is created, it cannot be changed. This means that any modification we try to make actually results in the creation of a new string object. It might sound a bit counterintuitive at first, but this immutability has some practical benefits. For example, in real-world scenarios, security-sensitive data like configuration keys or URLs often need to stay unchanged. Because strings are immutable, we can be confident that once they're set, they won't be accidentally altered somewhere else in the code. Now you might wonder, why are strings designed this way? Well, the main reason is to ensure consistency and safety. Since strings can be shared across different parts of a program without the risk of unintended modifications, it helps prevent bugs and makes our code more reliable. This characteristic also makes strings more efficient in certain situations, especially when dealing with constant data. So, understanding that strings are immutable helps us write safer, more predictable code, and it ties into our overall theme of understanding how data objects behave in Java. All right, let's talk about what the string pool is. In Java, when we create string literals, they don't just sit somewhere randomly in memory. Instead, Java stores these string literals in a special area called the string pool. This is a dedicated memory space designed to save memory by reusing common string values instead of creating a new object each time. Imagine you have a large application with many parts referencing the same status labels like success or failed. Without the string pool, each part might create its own copy of these strings, which would be pretty inefficient. But with the string pool, Java recognizes these common values and makes sure only one copy exists in memory. This reuse helps optimize memory usage, especially in big systems where there are many repeated string values. So, understanding the string pool helps us write more efficient Java programs by leveraging this feature. It's a simple but powerful way Java manages strings behind the scenes. So, when we talk about comparing strings in Java, it's important to understand the difference between the equals operator and the equals method. The equals operator actually compares memory references, meaning it checks if both variables point to the exact same object in memory. On the other hand, equals compares the actual content of the text. So even if two strings are different objects in memory, if their text is the same, equals will return true. A good real-world example of this is in login systems. When users enter their username and password, the system uses equals to verify if the input matches the stored credentials. This ensures we're comparing the actual text content, not just memory addresses. The key takeaway here is that equals checks if two references are the same object, while equals checks if their content is equal. Understanding this distinction is crucial for writing correct and reliable code, especially when handling user data or comparing strings in general. StringBuilder allows modification of characters without creating new objects. This means that when you're working with a string builder, you can change its contents directly, which is more efficient than creating a new string each time. A real-world example of this is when you're generating dynamic reports or logs. In these cases, the strings change frequently, and using StringBuilder helps improve performance because it avoids the overhead of repeatedly creating and discarding string objects. So, in essence, StringBuilder is a very useful tool when dealing with scenarios where strings need to be modified often and efficiently, aligning with our overall theme of optimizing performance in programming. StringBuffer is quite similar to StringBuilder, but there's an important difference to keep in mind. It is thread-safe, which means it can be used safely in multi-threaded environments. This makes StringBuffer particularly useful when multiple threads need to modify text at the same time without causing issues. For example, in a server application where numerous clients might be sending requests and modifying shared data concurrently, StringBuffer ensures that these modifications happen safely and consistently. So, while StringBuilder is faster in single-threaded situations, StringBuffer's thread safety is a key advantage when working with multiple threads. Understanding this difference helps us choose the right class depending on the context. In essence, StringBuffer provides a reliable way to handle text modifications safely in complex, multi-threaded applications, aligning with our overall goal of writing robust, efficient code. All right, let's talk about StringBuilder versus StringBuffer. StringBuilder is faster, but it's not thread-safe. That means if you're working in a single-threaded environment, it's a great choice because of its performance benefits. On the other hand, StringBuffer is thread-safe, which means it can be safely used across multiple threads, but this safety comes with a bit of a performance cost. In real-world scenarios, especially in backend APIs where performance is crucial, most developers prefer StringBuilder. It allows for faster string manipulation, which is often what you need in high-performance applications. So, the key takeaway here is to choose StringBuilder when thread safety isn't a concern, and opt for StringBuffer if you need that extra safety at the expense of some speed. This decision aligns with our overall theme of optimizing performance while maintaining reliability where necessary. Let's talk about how to reverse a string using the StringBuilder class. One of the simplest and most efficient ways is to use its reverse method. This method directly reverses the sequence of characters in the StringBuilder object, making the process quick and straightforward. In real-world scenarios, this technique is quite useful. For example, revering strings is a common coding interview problem, so it's great to have in your toolkit. Additionally, it's used in data transformation utilities, where you might need to manipulate or format data by revering strings as part of a larger process. So, by leveraging the reverse method of StringBuilder, we can perform string reversal efficiently, which ties into our overall theme of demonstrating practical, effective coding techniques. All right, let's talk about what a palindrome actually is. Essentially, it's a string that reads the same forward and backward. So, if you take the original string and compare it to its reversed version, you'll see they are identical. This comparison helps us determine whether a string is a palindrome or not. Now, why is this important? Well, you'll often encounter palindrome string checks in algorithm practice questions and coding assessments. They're a common problem because they help develop your understanding of string manipulation, comparison, and logical thinking. In the context of our overall theme, improving problem-solving skills, being able to identify palindromes efficiently is a useful tool in your coding toolkit. It's a simple concept, but it underpins many more complex algorithms you'll come across later. So mastering this idea not only helps with specific questions, but also sharpens your overall algorithmic thinking. So when we create a string literal in Java, it gets stored in what's called the string pool. This is a special area in memory that helps us reuse common strings efficiently. Now, if we use new string, we're actually creating a new object explicitly in the heap, which is separate from the string pool. This distinction is really important, especially when we're thinking about memory usage. For example, in real-world applications where you have millions of repeated string values, Understanding how these strings are stored can make a big difference. Using string literals can save memory because the JVM reuses the same object from the pool whenever possible. On the other hand, creating new string objects with new string results in separate objects each time, which can increase memory consumption. So the key takeaway here is that string literals are stored in the string pool for efficiency, while new string creates distinct objects in heap memory. This understanding is crucial for optimizing memory in large-scale applications with lots of repeated strings. All right, let's talk about the equals ignore case method. Essentially, this method compares two strings but ignores any differences in letter case. So whether the strings are in uppercase or lowercase, it treats them as equal if the characters match. This is particularly useful in real-world scenarios like validating usernames, where we generally don't want case differences to matter. For example, if someone enters John Doe or John Doe, the system should consider those the same. By using equals ignore case, we make our comparisons more user-friendly and flexible, aligning with the overall goal of creating intuitive and tolerant applications. In this slide, we're looking at the substring method, which allows us to extract a specific part of a string by specifying start and end indexes. Think of it as highlighting a section of text you want to focus on. This is especially useful when you need only a portion of data, like pulling out a country code from a phone number or a segment of an ID. For example, if you have a string representing a full phone number, you can use substring to isolate the country code. This technique helps us manipulate and analyze data more precisely, fitting into our overall theme of working efficiently with strings in programming. Remember, the key here is understanding how to select exactly the part of the string you need by defining the correct start and end points. All right, let's talk about the trim method. This function is really handy when you need to remove unwanted spaces from the beginning and the end of a string. Imagine someone accidentally adds extra spaces before or after their input. Trim takes care of that quickly. A common real-world example is form input validation, where users might accidentally include extra spaces, and we want to clean that up before processing. By using trim, we ensure that the data is neat and consistent, which helps avoid errors down the line. So, in the context of our overall discussion, trim is a simple but essential tool to ensure data quality and improve user experience. So on this slide, we're talking about the split function. Essentially, it takes a string and divides it into an array of smaller strings or substrings by using a specific delimiter. Think of it like slicing up a sentence into individual words or segments based on a character or set of characters you choose. This is really useful in many real-world scenarios. For example, when you're parsing CSV files, which are just comma-separated values, or when you're reading log entries that are separated by spaces or other delimiters. The key point here is that split helps us break down complex strings into manageable parts, making data easier to analyze or process further. It's a fundamental tool in data handling and manipulation, especially when dealing with structured text data. So, in the context of our overall theme, understanding how to split strings effectively allows us to handle and interpret data more efficiently, which is crucial in many programming and data processing tasks. So this slide is about the replace function, which is all about replacing characters or words inside a string. Essentially, it allows us to modify text by swapping out specific parts. Imagine you have a sentence or a piece of data, and you need to change certain words or characters. This function makes that easy. In real-world scenarios, you'll often see this used in data cleansing and text normalization within data processing pipelines. For example, if you're working with messy data that has inconsistent spelling or unwanted characters, replace helps clean that up efficiently. It's a simple but powerful tool that plays a crucial role in preparing data for analysis or further processing. By understanding how to use replace effectively, you can ensure your data is consistent and ready for the next steps in your workflow. Let's talk about using integer, parse int. This method is essential when we need to convert a string, like user input or data from an API, into a numeric value that we can perform calculations on. For example, if we receive a parameter as a string from an API request, we can use integer, parse int, to turn that into an integer. This is particularly useful in real-world scenarios where data often comes in as text but needs to be processed numerically. Remember, this method is straightforward but powerful, making your code more flexible and capable of handling various data inputs. Connecting this to our overall theme, mastering such conversions ensures our applications can interact seamlessly with external data sources and perform accurate computations. Now let's talk about using string value of. This method is essential when you need to convert a numeric value, like an integer, into a string. It's simple but powerful, especially when you're working with user interfaces or logs where you want to display numbers as text. For example, if you have an integer and you want to show it on the screen or include it in a log message, string value of makes that straightforward. It ensures your data is correctly formatted as a string, avoiding any type mismatch issues. This technique ties back to our overall theme of data conversion and presentation. Whether you're updating a label in a UI or writing to a log file, converting numbers to strings smoothly is key to clear, effective communication within your application. So remember, whenever you need to turn a number into text, string value of is your go-to method. Now, let's talk about converting text to different cases, specifically to uppercase or lowercase. This is a common operation when you're working with strings, especially in contexts like search engines or data processing. Essentially, these methods help us normalize text so that comparisons are more reliable. For example, before comparing two pieces of text, you might convert both to lowercase to ensure that differences in capitalization don't affect the match. The methods we're referring to are to uppercase and to lowercase. They are straightforward but incredibly useful in making your programs more flexible and user-friendly. So, whether you're handling user input or processing data, these functions are essential tools in your JavaScript toolkit. Now, let's take a closer look at the contains method. Essentially, this function checks whether a specific string contains another string within it. It's a simple yet powerful way to verify if a certain keyword or phrase is present in a larger text. This is especially useful in filtering systems, where we want to quickly identify relevant content, or in keyword detection, where we need to find specific terms within a body of text. By understanding how contains works, we can build more efficient and effective data filtering and search functionalities that are vital in many applications. Now let's take a look at how the char@ method works. Essentially, it returns the character at a specific index within a string. So if you have a string like hello, and you want to get the first character, you'd use char@ 0. It's a simple yet powerful way to access individual characters, which is especially useful when you need to perform checks or validations within your code. A real-world example of this is password validation. You might want to ensure that the first character of a password is uppercase or a special symbol. By using char@, you can easily check that first character and enforce your security rules. So, in summary, char@ is a straightforward method that helps you access specific characters in a string based on their position, making it an essential tool for many string manipulation tasks in programming. Strings are used in nearly every Java application. You'll find them in APIs, database queries, logging systems, user input, and data processing. Basically, they're everywhere. This slide summarizes why strings matter so much. They are fundamental to how programs communicate, store, and manipulate text. The key point is that understanding how strings work is essential for writing efficient and effective Java code. From building user interfaces to managing data, strings play a critical role. So, as we've seen throughout this presentation, mastering string handling helps you create more reliable and performant applications. In short, strings are not just simple text. They're a core part of almost everything we do in Java development. Today is day 4, and we're focusing on Java Collections interview questions. We'll explore the main types, list, set, and map, and see how they are used in real-world scenarios. Understanding these collections is crucial because they form the backbone of efficient data management in Java. As we go through each, I'll highlight their unique characteristics and typical use cases. Remember, choosing the right collection can significantly impact your application's performance and scalability. Stay tuned for the next video, where we'll deepen our understanding with more practical examples.